Have you ever wondered how these tiny squares of black and white can hold so much information? It is like a secret language that your phone instantly understands. From payment to menus to boarding passes, QR codes are everywhere. But do you know what is actually happening the moment you scan one? Stick with me till the end, and I promise, after watching this, you will never look at a QR code the same way again. You will see them not as a simple square, but as a powerful, compact data machine. Before going in depth, let's start with the basics. QR code stands for Quick Response. Unlike a barcode that stores data in just one direction, QR code stores information both vertically and horizontally. Now let's break down the anatomy of QR code and understand all its hidden components. At its core, a QR code is just a clever way to store information. Each black module represents a binary 1 and each white space is a 0. The standard version we can see most often has a size of 21 by 21 modules, which is a version 1. And each subsequent version has increment by 4 blocks on each axis. Here you can see the 21 cross 21 modules shows the version 1, the next 25 cross 25 shows the version 2, and so on. The next important concept is called finder patterns. These big squares in 3 corners are called finder patterns. They are like anchor points that help scanners identify this is actually a QR code and figure out its orientation. No matter how you rotate or flip a QR code, these finder patterns help your phone figure out the correct way to read it. Pretty smart, right? The next thing is called separators. See these white borders around the finder patterns that we just discussed? They are called separators. They act like a buffer zone so the scanner doesn't get confused between the finder patterns and the actual data. This little guy is called alignment patterns, the blue square. If the QR code is bent or wrinkled or you scan at an angle, this square helps the scanner adjust and still read the data correctly. These alternate black-white strips tells which version of QR code is this and how much data to expect. If it is 5 black-white boxes, it is version 1, and for the next version it is 9 and so on. These tiny sections store format information, basically the QR code settings. They tell the scanner things like error correction level that helps even if the part of the code is damaged, it still works. This image shows all the areas combined, including finder patterns, timing patterns, quiet zone, format information, and rest is actual data stored, which you can see in the gray shaded area here. Next, the important concept is called mask. To prevent big solid blocks which confuse scanner, QR codes use mask patterns, a special formula that flips some squares to create a balanced mix of black and white. There are 8 mask patterns available which are coded in these 3 bits which are represented in the orange box here. Here you can see 101 is mapped, that is 5 decimal, and represent the mask pattern in the checked boxes that you can see on the top right corner. Once you XOR mask with the QR code, you will get final code of black and white module. Let's look at the reading order followed by scanner. It starts from the bottom right and moves in a zigzag manner as shown in the image. The first 4 bits are the encoding mode that can be binary, numeric, alphanumeric, and Japanese kanji, which is represented in the yellow square box here. For the ASCII encoding mode, the next 8 bits specify the content length, that is 6 here as you can see, which is encoded in the green rectangular box. After that, every 8 bits is a content type. As you can see, 0110110, which is 110 in decimal, and when you convert it to ASCII character, it will be N, and similarly the next will be E, and so on. You can even refer to this table to quickly convert binary to ASCII values, and eventually you can decode the data in data which you have encoded. So next time you scan a QR code, remember you are holding a tiny printed piece of data magic that can connect you to almost anything in seconds. If you enjoy a breakdown like this, don't forget to hit like and subscribe. Until next time, keep learning and keep building.